Okay, hello, welcome to my channel. Now in this video, we're going to answer this question from the 2022 JEE Advanced math question. All right, it has to do with complex numbers. So we want to find the value of the modulo of z raised to the power 2, given that z is a complex number with non-zero imaginary part. All right, that means if you write z, the imaginary part is there, that is, it appears weird because it has a non-zero imaginary part. Now if this right here, this fraction right here is a real number, then the value of z squared is what? So that's what we asked to find, right? Okay, good. Now let's make an assignment. Let's say we assign this to some number, we call it a real number. So we say let y, okay, let's bring in y, let y be the real number. Maybe I should use little y. It's okay, it's just a matter of notation. Okay, that is 3z plus 4z squared. Okay. Okay, so having that, let's see what we have on the right hand side. Okay, so that means well, what I'll do here is addition of 0. I'm going to add 0 of the form. I'll subtract 6z and then I'll add 6z, right? Adding in the numerator. So I'm subtracting and adding the same thing. So in fact, that's addition of 0. And you notice that when we do that, this is going to become, well, if we subtract 6z from 3z to be negative 3z, which means that will agree with the denominator. So that place we can just have 1 plus 6z divided by the denominator, which is 2 minus 3z, right? We add it with 4z squared. Okay, that's great, isn't it? So just keep that in mind and we can clean this and then maybe close this back, all right? Okay, that's great. Now let's see what we have. Well, on the right hand, the right part of the fraction, I can factor z, okay, factor z and then factor 2 where possible, and that means we're going to have 1 plus, let's just maintain the 6z at the top, divided by, we can take this out to be 2, all right? We have that to be 1 over z plus 2z, then we put z outside, we subtract 3z from that. So as you can see, let me write this well. Okay, so as you can see, we factored out a 2 from 2 and 4, and we have 2 left, we have 2 outside, and then I factored out a z where 2 didn't have a z, that's why I'm having 1 over z here, and then one of these z's is outside, and then the 3 z's has not been touched. But as you notice that z is common in the denominator, we can use that to cancel the z at the top, and that tells us that we're going to have y to be 1 plus, right, 6 divided by just 2 into 1 over z plus 2z, and then we subtract 3 from that. Now you notice that this right here is a real number, right? That means that this part must be a real number, because provided z is a complex number with non-zero imaginary part, this is the only part that can make us not to have a real number. So this part must be a real number. In other words, that tells us that 1 over z must be the same thing as its conjugate. Every real number is the same as its conjugate. So that tells us that 1 over z, right, plus 2z must be the same thing as its conjugate, where the conjugate can be denoted by z with a bar on top, right? Because for this to be a real number, I'll trace it again, okay? For this to be a real number, this part must be a real number. I'm not saying z is a real number because z is given to be a complex number with non-zero imaginary part, but 1 over z plus 2z must be a real number. In other words, it must be the same thing as its conjugate. Okay, so that tells us that if you want to maybe take everything to the left hand side, you're going to have 2z, okay, let me put down the whole terms here first, 2z minus 2z with a bar, all right? We have plus 1 over z minus 1 over z with a bar, okay, that is equal to just 0 on the right hand side. But we can factor a 2 out here. We're going to have 2 into z minus z bar, right? And then we're going to add this with, well, let's combine the fractions here. When we combine that, we're going to have just z bar minus z, okay? We divide that by the product of these two. Notice this is a complex number multiplied by its conjugate. Their product will give us the square of their modulo, all right? You notice if you have, let's say, a complex number, let me just show you that, okay, here. Let's say a complex number a plus, okay, ib multiplied by its conjugate, that is going to be a minus ib, right? A, that will be a squared, then positive ib times negative ib, that will be positive b squared, right, where the I and the I will be -1. And you see this is exact same thing as the square root, the square of the square root of a squared plus b squared, which is the square of the modulo, right? So that's why I'm writing it there. So let me just clean this off. Okay, that's nice, isn't it? This is just equal to 0. Well, let's notice something that I will clean from the top to bottom, but let's just notice something. We notice that, well, here I can factor out z minus that. That means we're going to have z minus z bar, right, since it is common. And then into what? Into 2 plus 1 divided by the modulo, the square of the modulo of z equals to 0. Okay? Is that showing? Okay, that's showing anyway. Let me clean from here to here and then we're going to continue. Okay, so that's what we have. Now you notice that the product of these two terms gives us 0. That means at least one of them must be 0. So both of them may be 0, but at least one of them must be 0. Now let's see, can this one be 0? Well, that means that it's either this one is 0, that is 2 minus 1 over z squared, right, is 0, or let me write this one down here. It's either that is 0 or this right here is 0. So let me just put it here as this is z, or z minus z bar is equal to 0. Notice that z is a complex number with non-zero imaginary part, which means that it is not the same thing as its conjugate. Because if this is a complex number where b is non-zero, that's what it means for the imaginary part to be non-zero, then the conjugate will be a minus ib, which means these two are not the same. Okay, so that tells us that this difference cannot be 0 because that z is a complex number with non-zero imaginary parts. So the only part we have to be 0 is just this other side. Okay, so if that is equal to 0, let's make z the modulo of z squared, which is what we have to find the subject of formula, and that will be by subtracting 2 from both sides, multiply both sides by a negative result, by -1, and then take the reciprocal of both sides. That tells us that z bar square will be just +1/2. Okay, so if you subtract 2 from both sides and then multiply both sides by -1 and then you take the reciprocal, that's what you're going to have. And this right here is the value of z, the modulo of z, the square of the modulo of z, right? So that is it right there. Okay, hope you like this video. Please, thanks for watching and share this video with your friends, and don't forget to subscribe to my channel. All right, see you in our next video.